Hello, in this lecture we find out the length of line segment X. In the drawing we have a quarter circle, AOB is a quarter circle. Inside this quarter circle we have a semicircle, OB is a semicircle. And we also know that line segment AO equals to 10 units in its length. Our mission is to find out the length of this line segment AM that is equal to X. So first of all, we know that AOB is a quarter circle, and therefore this angle must be equal to 90 degrees. It is a right angle. In addition, because of the fact that AOB is a quarter circle, side AO and side OB, they are both the radii of this quarter circle, therefore they are equal to each other. But we know that side AO equals to 10 units in length, therefore OB must be also equal to 10 units. OB equals to 10 units. OB is not only the diameter of this quarter circle, but it is also, again, OB is not only the radius of this quarter circle, but it is also the diameter of the semicircle. So the diameter of this semicircle, OB equals to 10 units. Therefore, the radius must be equal to 10 over 2, that is 5. So the radius of this quarter circle equals to 5 units in its length. We define the center of this semicircle as P. Therefore, the radius OP equals to 5 units. So the radius OP of this semicircle equals to 5 units in its length. And the radius PB also equals to 5 units in its length. We define the point of tendency of tangent AM with this semicircle as Q. And then we join points Q and P together by a straight line. Point P is the center of the semicircle, point Q is the point of the semicircle itself, therefore PQ is the radius of this semicircle, that is equal to 5 units. The radius PQ of this semicircle, it is drawn to point Q, that is the point of tendency of tangent AM with this semicircle. And whenever we have a radius that is drawn to the point of tendency, then tangent AM will be perpendicular to the radius QP. If AM is perpendicular to QP, according to rule number 1, then this angle equals to 90 degrees, and this angle equals to 90 degrees. Okay. In the next step, we focus at this point, point A. Point A is an external point in relation to this semicircle. Why? Because point A is not located inside this semicircle nor on this semicircle, but it is located outside of this semicircle. Therefore, in relation to this semicircle, point A is an external point. From the external point, point A, we have two tangents to this semicircle, tangent AO and tangent AQ. And according to rule number 2, they must be equal to each other. Rule number 2 says that a tangent to a circle is perpendicular to the radius drawn to its point of tendency. But AO equals to 10, therefore AQ must be also equal to 10 because they are equal to each other. Okay. So, in the next step, we'll extend side AM and side OB by straight line until they touch each other. And we define this touching point of the extended side OB and side AM as point N. By doing this contraction, we created here the right big triangle, triangle AON. we define this angle ANO, as theta. So in the right triangle AON, this angle equals to theta, this angle equals to 90 degrees, therefore the missing angle here must be equal to 90 degrees minus theta. Why? Because 90 degrees minus theta plus theta is 90 degrees, and 90 degrees plus 90 degrees, it is equal to 180 degrees, that is the sum of the angles in any triangle. In the next step, we'll focus on the green right triangle, triangle QPN. According to the same logic, in the right triangle QPN, this angle equals to theta, this angle equals to 90 degrees, therefore this missing angle must be equal to 90 degrees minus theta. In the next step, we prove that the right big triangle, triangle AON, is similar to the right small green triangle, triangle QPN. So I write it down. We prove that the right big triangle, triangle AON, is similar to the small green right triangle, triangle QPN. Repeat again. We will prove that the right big triangle, triangle AON, is similar to the right small green triangle, triangle QPN. So, why triangle AON is similar to the green triangle QPN? First of all, those two angles, they are both equal to 90 degrees, therefore they are equal to each other. So this is the angle AON in the big triangle AON. And it is equal to this angle, that is actually angle PQN in the green triangle. Repeat again. Angle AON in the big triangle AON is equal to angle PQN in the green small right triangle PQN. They are both equal to 90 degrees, therefore they are equal to each other. In addition, this is angle theta. Angle theta is the common angle that belongs to both triangles, therefore we can write down that angle theta equals to itself. If we relate to angle theta, it is equal to, it belongs to the big right triangle AON, which will be angle ANO. And it is equal to itself. If we relate to angle theta as it belongs to the green triangle, it will be angle QNP. Okay, it will be angle QNP. Repeat again. This equation means that angle theta equals to itself. We just called to angle theta two different names. Angle theta is an angle that is a common angle that belongs to both triangles. And finally, those two angles, they are both equal to 90 degrees minus theta, therefore they are equal to each other. So actually this is angle OAN in the big triangle AON. And it is equal to this angle in the green triangle. This is actually angle QPN. Repeat again. Angle OAN in the big triangle AON equals to angle QPN in the green triangle. They are both equal to 90 degrees minus theta, therefore they are equal to each other. So we actually proved that all the three angles in the big right triangle AON are correspondingly equal to all the three angles in the small triangle, the small green triangle QPN, and therefore we actually proved that those two right triangles are similar to each other according to angle similarity rule. So I write it down. Triangle, the big triangle AON is similar, this is the sign of similar, to the small green triangle QPN according to angle similarity rule. And from the fact that those two right triangles are similar to each other, we will derive that the following relationship exists between their sides. We will derive that side AO in the big right triangle AON or side QP in the small right triangle QPN again AO over OP equals to side AN in the big right triangle AON over side PN in the small green triangle. Again, side equals to side AN over PN, and it is also equals to side ON in the big right triangle AON over side QN in the small right triangle QPN. Repeat again, we actually found out that AO over QP equals to AN over PN equals to ON over QN. AO equals to 10 units over OP equals to 5 units, and it is equals to AN. What is the length of AN? AN equals to AQ plus QM. That is to say, AN equals to AQ, that is 10, plus QN. So in total, AN equals to 10 plus QN. Over PN. What is the length of PN? PN in total equals to PB plus BN. That is to say, PN equals to PB, that is 5 plus BN. So in total, PN equals to 5 plus BN. And it is also equals to ON. ON in total is 5 plus 5 plus BN. That is to say, ON in total equals to 10 plus BN. Over QN. QN is the missing side, so we leave it as it is. 10 over 5 is 2, so 2 equals to 10 plus QN over 5 plus BN, and it is equals to 10 plus BN over QN. Those two sides are equal to each other, so we create the equation number 1 from those two sides that are equal to each other. So according to equation number 1, two equals to 10 plus QN over 5 plus BN. in the next step, here we have those two sides are also equal to each other, so we create equation number 2 from those two sides that are equal to each other. So according to equation number 2, 2 equals to 10 plus bn over qn. So those are the two equations that we created from this long equation. According to equation number 1, 2 equals to 10 plus qn over 5 plus bn. Here we will multiply this equation number 1, by 5 plus bn. And we get that according to this equation number 1, two times 5 plus bn equals to 10 plus qn. Here we'll open the brackets of this side of equation number 1 and we get that according to equation number 1, 2 times 5 is 10, 2 times bn is 2bn, so it is plus 2bn. That is equals to 10 plus qn. So here we have 10 on both sides of the equation, so 10 we get cancelled and left only with qn that is equals to 2 times bn. Check again, according to equation number 1, we actually found out that qn equals to 2 times bn. In the next step, we multiply this equation number 2 by qn, and we get that according to equation number 2, two times qn equals to 10 plus bn. According to equation number 2, 2 times qn equals to 10 plus bn. But we have already found out that according to equation number 1, qn equals to 2 times bn. Therefore, we can substitute qn in this equation number 2 by 2 times bn. We'll do it now and we get that according to equation number 2, 2 times qn. Qn according to equation number 1 is 2 times bn. That is equals to 10 plus bn. 2 times 2bn is 4bn. When this side of equation number 2, we have 4 times bn. That is equals to 10 plus bn. Here we subtract from this equation number 2 bn. And we get that according to this equation number 2, 4 times bn plus bn is 3 times bn. That is equal to 10. Here we divide this equation number 2 by 3. And finally, we get that bn equals to 10 over 3. bn equals to 10 over 3 units in its length. So we can write down in the original drawing that this line segment bn equals to 10 over 3 units. According to equation number 1, we actually found out that here qn equals to 2 times bn. So according to equation number 1, qn equals to 2 times bn, and bn is 10 over 3. So it is 2 times 10 over 3. So total qn equals to 2 times 10 is 20, so in total this expression equals to 20 over 3. In conclusion, we found out that according to equation number 1, Qn equals to 20 over 3 units in its length. Here, this line segment Qn is equals to 20 over 3 units in its length. Okay. In the next step, we'll find out the length of this line segment Qn. From the drawing, it is very easy to see that Mn equals to Qn minus Qn. Repeat again. From the drawing, it is very easy to see that Mn equals to Qn minus Qn. That is to say, Mn equals to Qn. We just right now found out that Qn equals to 20 over 3. Qn is 20 over 3 minus Qn. So in conclusion, found out that Mn in total equals to 20 over 3 minus Qn. So I can write down in the original drawing that this line segment Mn equals to 20 over 3 minus Qn. Again, Mn equals to 20 over 3 minus Qn. In the next step, we'll complete this quarter circle to a circle. So actually completed this quarter circle to a circle, and we will extend side BO of this quarter circle by a straight line until it touches the circle. We define the touching point of the extended side BO in this circle as point C. Point O is the center of this circle. Point C is the point on the circle itself, therefore OC is the radius of this circle. The radius of this circle is equal to the radius of the quarter circle, of course, and the radius of the quarter circle equals to 10, therefore the radius of the circle CO must be also equal to 10 units in its length. Okay. In the next step, I will present to you a new rule, rule number 14, and we will implement rule number 14 in our drawing. According to rule number 14, that is true in any circle, so in any circle, if we draw two chords, A, B, and C, D, from the common external point P, inside this circle, then the following equation will be 2 that PA times PB equals to PC times PD. So in the drawing we have a circle inside, and we have the common extreme point P. For the common extreme point P, we drew two chords inside this circle. The first chord is called AB and the second chord is called CD. So in this drawing, the following equation is true, that PA times PB equals to PC times PD. Again, PA times PB equals to PC times PD. We can actually implement rule number 14 in our drawing. Why? Because in our drawing, we have the common extreme point N. From the common extreme point N, we have here two chords inside the circle. The first chord is called MA and the second chord is called BC. So all the requirements of rule number 14 are met, and for that reason you can implement here rule number 14. According to rule number 14, NB times NC equals to NM times NA. Again, NB times NC equals to NM times NA. So I write it down. We'll focus on the common extreme point N. From the common extreme point N, we can implement rule number 14. According to rule number 14, NB times NC equals to NM times NA. Repeat again. In our original drawing, if we focus on the common extreme point N, we can implement rule number 14. According to rule number 14, NB times NC equals to NM times NA. NB is 10 over 3 times NC. What is the length? What is the length of this big line segment NC? NC, from the moment it is very easy to see that NC in total equals to 10 plus 5 plus 5, that is 20, plus 10 over 3. Again, NC or CN in total equals to 10 plus 5 plus 5, that is 20, plus 10 over 3. So NC in total equals to 20 plus 10 over 3, and it is equals to NM. NM or MN, it is the same, equals to 20 over 3 minus QM. NM equals to 20 over 3 minus QM. Times NA. What is the length of NA? NA or AN in total equals to AQ plus QN. That is to say, NN and AN equals to AQ, that is 10, plus QN, that is 20 over 3. So in total, AN equals to 10 plus 20 over 3. So we actually found out that 10 over 3 times 20 plus 10 over 3. Here we multiply 20 by 3 and then we divide it by 3 in order to have a common factor with 10 over 3. So 20 times 3 is 60 and 60 plus 10 is 70. So in total, in the numerator we have 70 over 3 That's equals to 20 over 3 minus qm. Here we multiply minus qm by 3 and then we divide it by 3 in order to have a common factor with 20 over 3. So the numerator we will have in total 20 minus qm times 3 is minus 3 qm. So in total in the numerator we have 20 minus 3 qm divided by 3. We have here 10 plus 20 over 3. Here we multiply 10 by 3 and then we divide it by 3 in order to have a common factor with 20 over 3. So 10 times 3 is 30 and 30 plus 20 is 50. So in total in the numerator we have 50 divided by 3. So here in both sides of the equation, on both sides of the equation we have in the denominator 3 times 3, that is 9. Therefore we will multiply this equation by 9 in order to cancel the denominator that is 9. So after we cancel the denominator, we'll have to leave with 10 times 70 in this side of the equation. That's equals to the other side of the equation, we'll have to leave with 20 minus 3 qm times 50. Here we divide this equation by 10 and we get that 10 over 10 is 1, so in this side of the equation we have to leave with 70. That is equals to 20 minus 3 qm times 50, and 50 over 10 is 5. So if I would have found out that that 70 equals to 20 minus 3 qm times 5. Here we will open the brackets on this side of the equation and we get that according to this equation 70 equals to 25, 20 times 5 is 100 minus 3 qm times 5 is minus 15 qm. So we shall find out that 70 equals to 100 minus 15 qm. Here we subtract 70 from this equation and we get that 70 minus 70 is 0 equals to 100 minus 70 is 30 minus 15 qm. Here we add to this equation 15 qm and we get that 15 qm equals to 30. Here we divide this equation by 15 and we get that qm equals to 30 over 15 is 2. Qm equals to 2. So actually this line segment qm equals to 2 units in its length. Our mission is to find out the length of this line segment AM, that is equal to x. Again, we have to find out the length of x that is equal to AM. Here, AM from drawings is very easy to see that AM in total equals to AQ plus QM. Again, AM equals to AQ plus QM. AQ equals to 10 and QM equals to 2. So it is 10 plus 2, that is 12. In conclusion, found out that x equals to AM, x that is equal to AM equals to 12 units in its length. And that is the answer to our question. I'll repeat again. Actually found out that the length of this line segment AM, that is equal to x according to what is given us in the question, is equal to 12 units. Okay? So in the next step, I will summarize the lecture. In this lecture, we found out the length of this line segment AM, that is equal to x, according to what is given as a question. In the drawing, we have a quarter circle. AOB is a quarter circle. Inside this quarter circle, we have this semicircle. OB is a semicircle. In addition, we know that the side AO equals to 10 units in its length. Our mission is to find out the length of this line segment AM that is equal to x. So, first of all, AOB is a quarter circle, and therefore this angle equals to 90 degrees. And side AO equals to side OB. They are both the radii of this quarter circle, therefore they are equal to each other. But we know that AO equals to 10 according to what is given as the question. Therefore OB, that is also the radii of this, that is also the radius of this quarter circle, must be also equal to 10 units. Here OB equals to 10 units in its length. Side OB equals to 10 units. But OB is not only the radius of this quarter circle, but it is also the diameter of this semicircle. So we know that the diameter of this semicircle OB equals to 10. Therefore the radius must be equal to 10 over 2, that is 5. The radius of this semicircle is 5. We define the center of this semicircle as P. Here we define the point of tendency of tangent AM with this semicircle as Q, and then we join points P and Q together by a straight line. Point P is the center of this semicircle, point Q is the point on the semicircle itself, therefore PQ is the radius of this semicircle, that is equal to 5 units. We have the radius PQ that is drawn to point Q. That is to say it is drawn to point Q. That is to say it is drawn to point Q. That is the point of tendency of tangent AM with this semicircle. And whenever we have a radius that is drawn to the point of tendency, then tangent AM will be perpendicular to the radius QP. If AM is perpendicular to QP, it means that this angle equals to 90 degrees and this angle equals to 90 degrees according to rule number 1. Then we focus on this point, point A. Point A is an external point in relation to this semicircle. Why? Because point A is not located inside this semicircle, nor on this semicircle. Therefore, it is an external point in relation to this semicircle. From the common external point A, we have two tangents to this semicircle, tangent AO and tangent AQ. And according to rule number 2, they must be equal to each other. Rule number 2 says that the lengths of two tangents from a common external point to a circle are equal. So the length of those two tangents AO and AQ that exist from the common external point A must be equal to each other. So AO equals to AQ, but AO is 10, therefore AQ must be equal to 10 units in its length. Then we extended side AM and side OB by straight line until they touch each other at this point. We define the touching point of the extended AM and BO as N. By doing this construction, we created the right big triangle, triangle AON. In this right big triangle, triangle AON, we define this angle, angle ANO as theta. And we focus on the right triangle AON. In the right triangle AON, this angle equals to theta, this angle equals to 90 degrees, therefore the missing angle must be equal to 90 degrees minus theta. Why? Because 90 degrees minus theta plus theta is 90 degrees, and 90 degrees plus 90 degrees, it is equal to 180 degrees. That is the sum of the angles in any triangle. Likewise, according to the same logic, if you focus on the green right triangle QPN, the green right angle QPN, this angle equals to theta. This angle equals to 90 degrees, therefore the missing angle here must be equal to 90 degrees minus theta. Then we proved that the green triangle QPN is similar to the big right triangle AON. Why the right triangle AON is similar to the green triangle QPN? First of all, those two angles are both equal to 90 degrees, therefore they are equal to each other. In addition, this is angle theta, that is a common angle, and it belongs to both triangles, so we can write down that angle theta equals to itself. And finally, those two angles, they are both equal to 90 degrees minus theta, therefore they are equal to each other. So we actually proved that all the three angles of the right big triangle AON are correspondingly equal to all the three angles of the green small right triangle QPN. Therefore we actually proved that those two right triangles are similar to each other according to angle similarity rule. Okay? And from the fact that those two right triangles are similar to each other, we derive that the following relationship exists between their sides. That side AO, the big triangle, over side QP in the small triangle equals to side AN in the big triangle over side PN in the small triangle, and it is also equals to side ON in the big triangle AON over side QN in the small triangle QPN, the small green triangle QPN. I repeat again, we will derive that AO over QP equals to AN over PN equals to ON over QN. AO is 10, QP is 5, AN. What is the length of AN? AN, from the drawing it is very easy to see that AN equals to AQ plus QN. That is to say AN equals to AQ plus AQ is 10 plus QN. So in total AN equals to 10 plus QN. Repeat again, AN equals to 10 plus QN over PN. What is the length of PN? PN in total equals to PB plus BN. That is to say PN equals to PB, that is 5 plus BN. So in total PN equals to 5 plus BN. Here PN equals to 5 plus BN. And it is also equals to ON. ON. What is the length of ON? ON in total equals to 5 plus 5 plus BN. That is to say ON equals to 5 plus 5, that is 10 plus BN. So in total ON equals to 10 plus BN. Okay, ON equals to 10 plus BN over QN. QN is the missing side, so we leave it as it is. 10 over 5 is 2. So in conclusion found out that 2 equals to 10 plus QN over 5 plus BN, and it is also equals to 10 plus BN over QN. Those two sides are equal to each other, so we created the equation number 1 from those two sides. That is to say, according to equation number 1, 2 equals to 10 plus QN over 5 plus BN. Those two sides are also equal to each other. Therefore, we created the equation number 2 from those two sides are equal to each other. According to equation number 2, 2 equals to 10 plus BN over QN. So here, those are the two equations that we created from the big equation. Here we multiplied this equation number 1 by 5 plus Bn, and we found out that 2 times 5 plus Bn equals to 10 plus Qn. Here we open the brackets of this side of equation number 1 and found out that 2 times 5 is 10 plus 2Bn equals to 10 plus Qn. Here we have 10 on both sides of the equation, so 10 will get cancelled, and we left only with Qn that is equal to 2Bn. So according to equation number 1, Qn equals to 2 times Bn. And we have an equation number 2, according to equation number 2, 2 equals to 10 plus Bn over Qn. Here we multiply this equation number 2 by Qn and found out that 2 times Qn equals to 10 plus Bn. But according to equation number 1, Qn equals to 2 times Bn. Therefore we can substitute this equation number 2 qn by 2 times bn. We did it and we found out that 2 times qn is 2 times bn. That is equals to 10 plus bn. 2 times 2bn is 4bn, so 4bn equals to 10 plus bn. Here we substitute bn from this equation number 2, and found out that 4bn minus bn is 3bn, so 3bn equals to 10. We divided this equation number 2 by 3 and found out that bn equals to 10 over 3. Here this line segment bn equals to 10 over 3 units in its length. According to equation number 1, we already found out that qn equals to 2 times bn. Now we can, so qn equals to 2 times bn, and bn is 10 over 3, so qn equals to 2 times bn is 10 over 3, so it is 2 times 10 over 3. 2 times 10 over 3 is 20 over 3. So in conclusion, found out that qn equals to 20 over 3. Here this line segment qn equals to 20 over 3 units in its length. Okay, then we found out the length of this line segment mn. From the drawing it is very easy to see that mn equals to qn minus qm. Again, mn equals to qn minus qm. Repeat again, mn equals to qn minus qm. qn is 20 over 3, so mn in total equals to 20 over 3 minus qm. Then I presented to you, we actually completed this quarter circle to a circle, and we extended side BO until it touches the circle. We defined the touching point of the extended side BO with this circle as C, and then I presented to you rule number 14 and implemented rule number 14 in our drawing. According to rule number 14 is true in any circle. So in any circle, if we draw two chords, A, B, and C, D from the common external point P, then the following equation will be true, that PA times PB equals to PC times PD. So we have a circle and we have the common external point P. From the common external point P, we draw two chords inside this circle, chord AB and chord CD. So in this drawing, the following equation will be true, that PA times PB will be equal to PC times PD. Again, PA times PB equals to PC times PD. We can implement rule number 14 in our drawing. Why? Because in our drawing, we have the common external point N. From the common external point N, we have two chords inside this circle, chord AM, that exists from point N, and we have a second chord that exists from point N, that is called BC. So all the requirements of rule number 14 are met, and therefore we can implement rule number 14 in our drawing. According to rule number 14, we get that NB times NC equals to NM times NA. Again, NB times NC equals to NM times NA. Repeat again, according to rule number 14, if you focus on the common external point N, NB times NC equals to NM times NA. NB is 10 over 3. NC, what is the length of NC? NC, in total, NC equals to 10 plus 5 plus 5 plus 10 over 3. Again, NC in total, or CN in total, equals to 10 plus 5 plus 5. That is 20 plus 10 over 3. So in total, CN or NC equals to 20 plus 10 over 3. Again, NC equals to 20 plus 10 over 3, and NB equals to 10 over 3, and it is equal to MN. We already found out that MN equals to 20 over 3 minus MQ, or QM. Again, MN equals to 20 over 3 minus QM. Again, MN equals to 20 over 3 minus QM. Times NA. NA, what is the length of NA? NA in total equals to AQ plus QN. AQ is 10 and QN is 20 over 3, so AN in total equals to 12. AN in total equals to 10 plus 20 over 3. Repeat again, an in total equals to 10 plus 20 over 3. So here we have 10 over 3 times 20 plus 10 over 3. Here we multiplied 20 by 3 and then we divided by 3 in order to work on factor of 10 over 3. 20 times 3 is 60 and 60 plus 10 is 70, so in total in the numerator here we have 70 divided by 3 and it is equal to 20 over 3 minus qm. Here we multiplied minus qm by 3 and then we divided by 3 in order to work on a common factor with 20 over 3. So in the numerator we have in total 20 minus qm times 3 is minus 3qm. So in total in the numerator we have 20 minus 3qm divided by 3 times 10 plus 20 over 3. So we multiplied 10 by 3 and then we divided by 3 in order to work on factor with 20 over 3. 10 times 3 is 30 and 30 plus 20 is 50, so in total the numerator we have 50 divided by 3. So on both sides of the equation, in the denominator we have 3 times 3, that is 9. Therefore we multiply this equation by 9 in order to eliminate the denominator 9. After we eliminated the denominator 9, we left only with, in this of the equation, 10 times 70. On the other side of the equation, we left only with 20 minus 3qm times 50. Then we divided this equation by 10. 10 over 10 is 1, so in this side of the equation we left only with 70. In the other side of the equation we have 20 minus 3qm times 50. And 50 over 10 is 5, so in total in this side of the equation we left only with 20 minus 3qm times 5. So conclusion found out that 70 equals to 20 minus 3qm times 5. Here we open the bracket on this side of the equation and found out that 70 equals to 20 times 5 is 100, minus 3qm times 5 is minus 15qm. Here we subtracted 70 from this equation and found out that 70 minus 70 is 0 and 100 minus 70 is 30. So in total 0 equals to 30 minus 15qm. Here we added 15qm to this equation and found out that 15qm equals to 30. Here we divided this equation by 15 and finally found out that qm equals to 2 units. Here this line segment qm equals to 2 units in its length. Our mission is to find out the length of line segment AM that is equal to x. Again, we have to find out the length of line segment AM that is equal to x. From the drawing it is very easy to see that AM in total equals to AQ plus QM. Again, AM equals to AQ plus QM. Repeat again, AM equals to AQ plus QM. AQ is 10 and QM, we just now found out that QM equals to 2. So AQ plus QM is 10 plus 2, that is 12. In conclusion, found out that x is equal to AM equals to 12 units in its length. I repeat again, this line segment AM that is equal to x, it is equal to 12 units in its length. Okay, thank you very much.